During last video, we discussed about the concept of entropy. And entropy, it is a thermodynamic property, which is a measure of molecular disorder or randomness. It is a state function, and for crystalline solid, entropy is comparatively less, and for gases, entropy is highest because in case of gases, there is a highest disorder, and entropy is also highest. When Now in this video actually we are going to discuss some examples of entropy change. When iodine solid, it is dissolved in water to get aqueous iodine solution, there is an increase in entropy because solid is converted into its solution. Solid, it is dissolved in solvent to get a solution. So for initial state or for molecular iodine, suppose entropy is S1, and when it is dissolved in water, its entropy is S2. So here S2 is greater than S1 because when iodine is present in solution form or in liquid state, then iodine molecules move randomly, randomness is more, and therefore S2 is greater than S1. And for this change, entropy is positive. So delta S is positive. How delta S is calculated? S2 minus S1. S1 is the entropy of initial state and S2 is entropy of final state. So S2 minus S1, this is the delta S. Consider another example when hydrogen gas is converted into, or molecular hydrogen, when it is converted into atomic hydrogen, the number of particles increases. In between two hydrogen atoms of hydrogen molecule, there is a covalent bond. Now when this bond breaks, hydrogen molecule gets converted into hydrogen atoms. And suppose Avogadro number of hydrogen molecules are present in 1 mole of hydrogen, and when it is converted into hydrogen atoms, the number of particles will be 2 into Avogadro number. In this way, when hydrogen molecule is converted into hydrogen atoms, number of particles increases and therefore entropy also increases. Say S1, it is the entropy of H2 molecule, and S2, it is the entropy of hydrogen atoms. Then atomic hydrogen is having more entropy as number of particles are more, and therefore for this change the entropy increases, delta S is positive. Consider the third example. When 2 moles of hydrogen gas is mixed with 1 mole of oxygen gas to form 2 moles of liquid water. Here gaseous reactants are converted into product which is in liquid state, and as gas is converted into liquid, entropy must decrease. So here S1, it is the entropy of reactants which is more, and S2, it is the entropy of product, it is less because product is in liquid state. So during conversion of reactants into product or gas into liquid, disorder decreases and therefore entropy change is negative, entropy decreases. Consider another example, that is the decomposition of calcium carbonate solid into calcium oxide solid and carbon dioxide gas. In this example again, solid is converted into gas and therefore entropy increases. Say S1, it is the entropy of calcium carbonate solid, it is less because it is a solid, and S2, it is the entropy of products. In product there is a gas and therefore S2 is greater than S1 and therefore disorder increases during this change. Solid is converted into gas, one of the product is gaseous, therefore disorder increases, delta S also increases or delta S is positive. So these are the examples of entropy change. Here always you keep in mind, when solid is converted into liquid, entropy is positive. In a gas, suppose molecules are converted into atoms, number of particles increases, entropy increases. When gas is converted into liquid, entropy decreases, and during chemical reaction, when solid is converted into gas, there is a increase in entropy, or change in entropy is positive. Now next point is quantitative definition of entropy. The entropy change of a system in a process is equal to the amount of heat transferred to the system in reversible manner divided by absolute temperature at which the heat transfer takes place. This is the quantitative meaning of entropy. And the mathematical expression for entropy change is delta S is equal to Q reversible upon T. Q reversible, it is the heat supplied to the system reversibly at absolute temperature equal to T. And the unit of change in entropy, that is delta S, it is joules per Kelvin. Now from this mathematical expression, it is clear that Q reversible, that is heat supplied to the system, it is directly proportional to entropy change. Meaning of this is, as more and more heat supplied to the system, its kinetic energy increases, and when kinetic energy increases, disorder increases, randomness increases, and therefore delta S also increases. So delta S, it is directly proportional to heat supplied to the system. And from this equation, it is also clear that delta S is inversely proportional to absolute temperature. Meaning of this is, at low temperature, system has small amount of disorder. Actually, disorder depends upon temperature, and as temperature increases, kinetic energy increases, and therefore randomness increases, entropy also increases. There is no any doubt. But at low temperature, as system is having small amount of disorder, and addition of given amount of heat to the system results in significant increase in disorder at low temperature, and hence delta S is high at low temperature. On the other hand, if the system has high temperature, it already has large amount of randomness. At that instant, when heat is supplied to the same quantity of heat is supplied to the system, it produces only a marginal increase in disorder, and therefore there is a slight increase in entropy at high temperature. So this indicates that delta S is inversely proportional to absolute temperature. Analogy of this is, suppose there is one person who is having 2000 rupees in his bank account, and that person wins 50 lakh rupees in Kaun Banega Karodpati. Now that person will be very happy because his account balance is increased substantially. Initially it was hardly 2000 rupees, and now account balance is more than 50 lakh rupees. He will be very happy. Suppose there is another person who is having 50 crore rupees in his account, bank account, and he also wins 50 lakh rupees in Kaun Banega Karodpati. Now the second person will not happy that much as the first person, because in the bank account of second person, comparatively there is a marginal increase. Already second person is having 50 crore rupees. In that 50 lakh rupees are added. He will be happy, no doubt, but happiness will be not as much as the first person. In same manner, at low temperature there is a marginal disorder or entropy, and at that point when heat is supplied, there is an increase in entropy, and therefore there is a substantial increase in entropy at low temperature. On the other hand, at high temperature already entropy is very high, and at high temperature, suppose heat is supplied to the system, the supplied heat will, of course, it will increase the entropy, and there will be marginal change. It is like that. Now next point is entropy and spontaneity, that is the second law of thermodynamics. Statement is the total entropy of the system and surroundings increases in a spontaneous process. So here entropy change total or total entropy change, it is equal to delta S system plus delta S surroundings. Now when delta S total it is greater than 0, the process will be spontaneous. In other words, for a spontaneous process, delta S total it should be greater than 0, and delta S universe it is always 0. Meaning of this is, according to second law of thermodynamics, entropy of universe increases day by day and it is always greater than 0. Delta S universe is always greater than 0. Now here most important thing is spontaneity is decided by considering entropy of system and surroundings both, and it is not decided by considering entropy of either system or surrounding. We need to consider entropy of system as well as surrounding. We'll take example. Suppose there is a chemical reaction in which hydrogen gas is mixed with oxygen gas to form liquid water. As gas is converted into liquid, entropy of this system decreases, and therefore delta S system it is minus 372 joules per Kelvin. Suppose this reaction is carried out at 278 Kelvin, and this is exothermic reaction, and heat evolved is minus 572 kilojoule. Now here 572 kilojoule heat is released during this reaction, which is received by the surrounding, and therefore there is a change in entropy of the surroundings. So delta S surrounding it is equal to Q reversible upon T, where Q reversible it is the heat supplied to the surrounding at absolute temperature T, which is 278 Kelvin. Now we know the Q reversible, it is 572 minus 572 kilojoule. It is converted into joule, 572000 upon 298. It is the absolute temperature. So delta S surrounding it is equal to 1919 joules per Kelvin. Now delta S system is already known, minus 372 joules per Kelvin. So delta S total it is equal to delta S system plus delta S surrounding, it is equal to minus 327 plus 1919. So it is equal to plus 1592 joules per Kelvin. It is a positive. So delta S total is positive for this reaction, and therefore for this reaction, as delta S total is greater than 0, this reaction is spontaneous even though delta S system is negative. This is most important, because to check the spontaneity of a chemical reaction, delta S total is considered and not delta S system. Now accordingly, three conditions we need to consider. If delta S total is greater than 0, process is spontaneous. If delta S total is less than 0, process is non-spontaneous. And if delta S total is 0, the process is at equilibrium. So these are the three conditions. So here summary of this point is, according to second law of thermodynamics, the total entropy of system and surroundings increases in a spontaneous process, and to check spontaneity of the process we need to consider entropy of system and surroundings. System and surroundings. But actually in practice most of the time the entropy of system is considered. Okay, so this is about the second law of thermodynamics.